Good morning everyone, my name is Oscar. Today I'm going to present the paper entitled DBA Algorithm for Cooperative Resource Sharing among EPON Customers, authored by Carlos Trujillo and Nelson Fonseca. This paper presents the results of a novel mechanism for supporting resource sharing for cooperative customers in EPON networks. So the outline of this presentation is as follows. First, the problem is presented, including the contextualization. Next, the solution is introduced. It includes an EPON algorithm which allows bandwidth sharing among cooperative customers. Finally, some results on network utilization and delay for traditional and cooperative customers are presented. So, in order to present the problem, let me introduce the topic. This figure illustrates how the network load varies along the day in a cellular scenario. Typically, base stations are deployed through the city, which includes residential and office areas. Moreover, these base stations are often dimensioned their backhaul for busy hours, which means that when users move from office to residential areas occurs a considerable wastage of resources. Moreover, the peak of the traffic load can be even 10 times higher than the lowest traffic of the day. Thus, the traffic distribution varies depending on the area and the time of the day. Moreover, the busy hour traffic continues to grow more rapidly than the average traffic. According to the Cisco forecast in 2022, the peak traffic load can be 6 times higher than the average traffic. Passive optical networks have an important role in the broadband access providing. Moreover, fiber-to-the-sheet solutions can provide multiple services to adapt the network for the customer requirements. Thus, infrastructure service provider can support diverse services and business models for customers. In this case, PON customers can be residential subscribers, single or multi-site enterprises, or other service providers such as mobile network operators, virtual network operators, antennas owing upon a slice. Thus, the service provider is owing the PON is responsible for the management of physical resources and the allocation of bandwidth for PON customers. However, PON customers usually have different traffic loads within a given time period. This is some customers can be overloaded while others are underloaded. For example, mobile network operators, customer 1 in this image, have high traffic demands in commercial areas during the day and low traffic demands during the evening and night. Moreover, residential subscribers, customer 2 and 3 in this image, have low traffic demands during the day and high traffic demands during the evening. Thus, mobile network operators and residential customers may cooperate and share resources to increase their capacity. Moreover, diverse customers coexisting in the same optical network infrastructure creates several challenges to the design of optical network algorithms. Particularly, bandwidth distribution will be highly affected due to these customers request high and unbalanced load with large spatio-temporal traffic variability. Moreover, the DBA algorithms just guaranteed bandwidth at the individual and customer level. As a result, some customers in a given time period are on the utilization of guaranteed bandwidth while other customers are overloaded. On the other hand, the more recognized DBA algorithm for EPON is the interval polling with adaptable cycle time, known as IPAC, which guaranteed bandwidth to individual owners according to a service legal agreement. Moreover, a mechanism to guarantee bandwidth to a group of owners of a same customer, known as multi-owner customer, was proposed by the authors of this paper. This mechanism, called as MOS IPAC, allows the sharing of unused bandwidth among owners of the same multi-owner customer. In MOS IPAC, the OLT waits the arrival of report messages from all owners of the same multi-owner customer, in this image owners in blue, before issue and send the gate message to the corresponding onus. In this way, the bandwidth of a multi-ONU customer can be distributed among all ONUs of itself. Conversely, if the report message comes from a traditional customer, a customer which has only a ONU in EPON, the get message is issued and sent immediately. Now let me explain the solution. So our proposal is to allow EPON customer to share the unused bandwidth among themselves without affecting their guaranteed bandwidth. Thus, the proposed algorithm can support cooperation among customers. The proposed DBA algorithm is called as IPAC with Cooperative Customer Support, CS-IPAC. In this proposed, a customer can join a cooperative group to share the unused bandwidth with other customers that belongs to the same group. Moreover, the proposed DBA allows bandwidth sharing to three types of customer. Traditional customer having a single SLA per ONU. In this example, customers in yellow. Multi-ONU customer having a multi-ONU SLA, such as customer 3, and cooperative group of customers, such as customer 1, 2, and part of the traditional customers. Most IPAC scheme is modified to also wait for report messages from ONUs belonging to the same cooperative group before sending an extra gate messages to overloaded ONUs in that group. I show this figure, customer 1 in orange, customer 2 in red, and customer 3 in blue are in the same cooperative group of customers. Moreover, in the cycle N-1, customer 1 is overloaded and the other two customers are underloaded. When a report message comes from a cooperative customer, such as customer 1, the OLT waits for the arrival of report message of all customers that belongs to the same cooperative group, in this case customer 2 and customer 3, before sending an extra gate message to the overloaded ONUs in that group, in this case ONUs which belong to the customer 1, ONU 1 and ONU 2. In this case, the customer 1 can send two bursts of data for each ONU. For example, ONU 1 has a first opportunity to send data here and a second opportunity to send data here. All opportunities are in the same cycle. Now, this figure summarizes the CS-IPAC algorithm which resides at the OLT. For each report message received by the OLT, it is verified whether this report message comes from a traditional customer or a multi-ONU customer. In the first case, the OLT sends immediately the gate message according to the IPAC with limited policy. However, if the report message comes from a multi-ONU customer, the OLT stores the report message and waits for the report messages from all ONUs in the same multi-ONU customer before issue and send the gate message to those ONUs. Moreover, the OLT also waits for the report messages from all ONUs belonging to the cooperative group before issue and send the gate message to the cooperative customer. When the OLT has already received all report messages from ONUs of a multi-ONU customer, the bulk run generating function is employed. Then it executes an excess bandwidth distribution algorithm for the ONUs belonging to a multi-ONU customer. In this way, the total excess bandwidth for underloaded ONUs belonging a given multi-ONU customer is distributed among the overloaded ONUs belonging to the same customer in a per granting cycle basis. Now, if the report message comes from overloaded ONUs which belong to a cooperative group, the report is stored for a second round of bandwidth distribution. Finally, when all report messages from a cooperative group arrive at the OLT distributes the excess bandwidth from the underloaded ONUs to the overloaded ONUs in that group according to a fair access policy. Subsequently, a send get message is issued and sent to the overloaded ONUs in the cooperative group. Now, let me show the simulation results. The performance evaluation of the proposed mechanisms was performed by using the EPON simulator, EPON sim, These are the main parameters used in the simulation. The aims of this scenario is evaluate the bandwidth distribution among cooperative customers and analyze the isolation at customer level. In this case, it's assumed that the customer 2 is underloaded and customer 3 is overloaded, with aggregate load equal to 0.7 and 1.2 of the aggregated warranted bandwidth respectively. Moreover, customer 1 has an aggregated load varying from 0.7 to 1.2 of his aggregated warranted bandwidth. This figure shows mean values and confidence intervals derived from 50 independent replications. We compare the throughput when vary the load at customer 1 and employing most IPAC and CS IPAC algorithms. As you can see, CS IPAC produced for the overloaded customer, in this case customer 3, line in orange, greater average throughput values than those given by most IPAC, line in yellow. Moreover, for the underloaded customer, in this case customer 2, CS IPAC and most IPAC algorithms produce the same average throughput values, line in red and pink. Moreover, for the customer which has a variable load, in this case customer 1, CS IPAC produce throughput values up to 5% higher, line in dark green, than those produced by most IPAC, line in green, under overloaded condition. These important improvements are consequence of the cooperation among customers that our proposal provides. Moreover, the throughput of customer 3 decreases as the load of customer increases when CS IPAC is used because our mechanism employs the fair access policy to distribute the excess bandwidth between overloaded customers. Note that when customer 1 and customer 3 has the same offered load value, in this point, CS IPAC produces the same throughput for these cooperative customers. The results show that the proposed algorithm provides a fair distribution of bandwidth among cooperative customers. So, to conclude, let me summarize this presentation. We introduce an algorithm that supports bandwidth sharing among cooperative customers in EPON networks. We also have compared the performance of a proposal scheme with the most IPAC algorithm, which does not support bandwidth sharing at customer level. As a result, we have highlighted that CS IPAC algorithm increases network utilization to cooperative customers and maximizes revenues for service providers which can employ new business models. Thank you very much. Any question?